Hello everyone, welcome to the solution of LeetCode problem 560 named Subarray sum equal k. In this problem, we are given an integer array nums and the integer k. We have to return the total number of subarrays whose sum equal to k. Now, a subarray is a continuous non-empty sequence of element within an array. Suppose in the first example, if we see that the array contains three elements, which is 1, 1, and 1, and the value of k is 2. So now the subarray which contains the first two elements is 1 and 1, and their summation is 2. So it is one possible subarray. Now the subarray of the last two elements is 1 and 1, and their summation is 2. So it is one possible subarray. So we can see that for the example 1, there are two possible subarrays where the sum of the element is 2. So here we have to return 2. Now in the second example, the array contains three elements, which is 1, 2, and 3, and the value of k is 3. So here we can see that if we take the subarray of the first two elements, which is 1 and 2, their summation will be 3, which is exactly equal to the k. So it is one possible subarray. Now, if we take the last element as a subarray, whose summation will be 3, because it has only one element, which is 3. So here it is one possible subarray. So we can say that there are two possible subarray where the summation of each of the element is 3. Now, here we have to return 2. I hope you understood the problem statement. Now the constraint are the array length can be in between 1 to 2 into 10 to the power 4, and each of the array element can be in between minus 1000 to positive 1000. And the value of k can be in between minus 10 to the power 7 to positive 10 to the power 7. I hope you understood the constraint. Now let's move on to the algorithm. Now, to solve this problem, let us take the first example here. The first example contains three elements in the array, which is 1, 1, and 1. And here, the value of k is 2. So we have to find the subarray whose summation is 2 for each of the element. Now, if we take this subarray and this subarray, we can say that both of the subarray, their sum of all of the element is 2. So here we have to return 2 as answer. Now the problem is, how can we solve this problem? We can solve this problem by simply using the prefix sum algorithm. Now here, let's try to understand the intuitive approach clearly. Suppose we have several numbers, which is, it is not 0, it is dot, 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 dot. Suppose our array has these several numbers. Now, suppose the value of k is 3. Let us assume. Now, let us understand what is the basic purpose of this prefix sum counter. Now here, suppose this element's sum is equal to 5. Suppose all of this element and their sum is 5. Let's assume. Now, as our array can contain negative element, though it is not necessarily possible that if the size of the subarray is longer, then the summation will increase. The summation may decrease because of the negative element. Suppose for this range, the summation is 5. Now, let's assume for this range, the summation is 2. And for this range, the summation is 2. Now, for this summation 5, what will be the answer of the sum minus k, which is 5 minus 3, that means 2. So here, if for this portion 5, we discard some of the portion which has the prefix sum of 2, we can find another portion which has the prefix sum of 3. Suppose this portion has the prefix sum of 5, right? So if we discard this portion which has the prefix sum of 2, so we can say that this portion of the array will has the prefix sum of 3. So it is one possible subarray which has the prefix sum of 3 exactly equal to k. This is one possible scenarios. Now again, suppose if this portion of the array has prefix sum of 2 again, now we can say that this portion of the array has the sum of 3, right? Because all of the element in this range has sum 5, and if we discard the prefix sum of these elements in this range, then the summation of this element will be 2. So we can say that we have to count the frequency of the prefix sum to determine how many times it appears before. So I hope you understood the intuition with this simple example, k is equal to 3 and this large array. Now let us try to simulate this example using the given example. Or let us try to understand the algorithm using the given example. Now at first, let's erase all of this thing. Now, for this element 1, their prefix sum will be 1, right? So we have to determine the sum minus k, where the sum is 1 and the value of k is 2, which is minus 1. So we have to determine whether our minus 1 is presented in the prefix sum array or not. So we can clearly see that our minus 1 is not presented here, right? So it is not possible for this subarray to become the summation equal to k. Now wait, we have to add a default value to the prefix sum array, which is initially the value of the 0 or is 1, because it is the default value. There might be possible that in this subarray, their sum is 2, right? So the value of sum minus k will be 2 minus 2, which is 0. So we can say that it has a default prefix subarray which has the summation of 0. So here we have to see whether the element 0 is currently presented in the prefix sum array. Yes, it is presented here. Okay, so this is the basic intuition of the default value 0. Now again, let us try to understand the algorithm using these examples. Here, suppose for the first element, the prefix sum will be 1. So now we have to determine whether the value of 1 minus 2, which is sum minus k, is presented in the prefix sum array or not. So we can say that minus 1 is not presented here. So we cannot increment the answer. But wait, before moving to the next iteration, we have to insert this portion of the subarray into the prefix sum count. So here we can say that we have the prefix sum 1 and currently the count is 1 for this portion. Now, for this portion of the subarray, the prefix sum will be 2 or the sum will be 2 and the value of sum minus k will be 2 minus 2, which is 0. So we have to determine whether the value of 0 is presented in the prefix sum or not. So here we can see that it is presented here. So currently our answer will be 1. it is this count. So we have found one possible subarray here, where the summation of all the elements is equal to 2. Now, let us try to take this portion of the subarray. So here we can see that for this portion of the subarray, their sum will be 3. So the value of 3 minus 2, which is sum minus k, will be 1. So suppose for this portion of the subarray, if we discard any of the subarray which has the sum 1, then we can say that for the remaining subarray, their summation will be 2. Because this is the pure mathematics. If this portion has the sum of 3 and this prefix has sum of the 1, then definitely this portion of the subarray has the sum of 2. So we have to determine whether in our prefix sum counter there is a entry of 1 or not. So we can say that there is a entry 1 and which appears 1 time into the array. Or we can say that the prefix sum 1 appears 1 time into the given array. So now we have to add the counter value 1 to the answer. So currently our answer will be 1 plus 1, which is equal to 2. And finally, as we have completed the iteration, we have to simply return these 2. I hope you understood the algorithm. Now let's move into the code. In this problem, the code is pretty simple. At first, we are given a function named subarraysum, which has a parameter vector and the integer k. Now here, we are using one map, and initially, the prefix sum value will be 0, and the answer value will be 0. The default entry for the 0 will be 1 in the map. Now, we are iterating each of the element in the given input array, and we are calculating the sum. And now, we have to determine the remaining value, so or the extra value. So here the extra value will be sum minus k. Now we have to check whether the entry of this extra value is presented on the map or not. If it is presented, that means we have to simply increment the answer with the frequency of the extra value. After that, we have to increment the counter value of the current prefix sum. Finally, we have to return the answer. I hope you understood the code. Now let's move on to the time and space complexity analysis of this program. In this program, the time complexity is big O of n because we have to iterate each of the element in the array. And the space complexity is also big O of n because we are using extra memory map data structure to solve this problem. And in the worst case, the size of the map can be equal to the size of the input array. So we can say that the space complexity is also big O of n. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.